Hey, oh, wow, that looks a bit red, doesn't it? Flipping heck. How are we all doing? Wow, that top looks really red. I've got this on because it's really thin and light. It's boiling here at the moment. Hopefully everything's working. We've got microphone, we've got pictures. It looks like we've got pictures. Yeah. Catch you later, Tim. Who have we got in then? Let's have a quick look. So I'm absolutely amazed that I managed to get on live. And look at my on-air sign. Look, whoa! I'm absolutely amazed that I managed to even get on for 2 o'clock today. Not been feeling too special, to be fair. Not been feeling well at all, actually. But I had originally planned to do Martin's cassette deck because I've got the bits in for it. But it's just too hot, and I really don't need to do a long stream today. So I thought I'd see if I could find something else. I'd already prepared to do the radio cassette recorder, but then it was lastminute.com changed my mind. I knew that I needed to build a little kit to test something, and we'll have a look at that in a minute. Plus, John Turner very kindly sent me out a mini whip aerial, and he reckons it'll beat my long wire. So I've been rummaging around in the shed and trying to find bits to put together to actually make this thing. God, that is so red on camera. I don't know if it's coming across. But yeah, so I've got a few bits put together to try and make this thing, and I've got a few ideas. I'm not sure how it's going to pan out quite yet. Yeah, not 100% sure how I'm going to do it yet, but I'm going to do it. And I doubt whether we'll get a chance to finish it today, but I've got myself a fiberglass pole to mount it on. And I found a load of coax in the shed, so we are looking good. Let's quickly catch up with the rest of the chat. Then we've, as a lot of you probably know, we have got some bad news. So we've got Joe's in, Bob Anderson. Wasn't sure I'd be up for a stream today. Yeah, it's been a bit manic here actually, Bob. Andrew's in. As, how are you, mate? Aston's in. It's gone too far. Yeah, I know. Well, it's 27 degrees it is here today at the moment. Mrs. Mrs. Cruncher sat outside in it. Radio Electronics Hub, welcome. JJ. I keep forgetting you're JJ. JJ. Nick's in. Hi, Nick. Yeah, hot for you as well. We love to moan about the weather, don't we, us Brits? Andrew's in, Electrosound. Tim's in and out. Back later. Hang on, we got more. Hopefully the mic's working. No one's shouted at me yet, so fingers crossed. Happy birthday yesterday, Benji. You can hear me, but you can't see me. Yeah, that is carnage while I was trying to find the stuff to do this live stream. I've just literally wrenched everything out. The problem I got is I need some project boxes, and I've got some somewhere, and I cannot for the life of me find them. I've got some very nice aluminium ones, and I've got some little plastic ones as well, and I need both of those for this project. Dave Rhodes, afternoon to you. Baz is in. Hi, Baz and Ricardo. Sunny northwest Iberian. You're used to that sort of weather. Andy 84251, welcome in. Shaving foamed speaker grill cloth. Oh, that's Manuel's favourite thing, isn't it? Can we get this limit camera toned down a bit? Video defaults. No, I can't. It is what it is. It is what it is. That's so bright, isn't it? Are you able to see me yet? Two couldn't see me. Oh, you can see me. Okay. You can see me and hear me. So yeah, unfortunately, this week on Monday, I had some very sad news that our good friend Chris Milkey had passed away. He passed away unexpectedly. Actually, I knew he wasn't very well, but certainly it wasn't something that I expected whatsoever. His wife Carmen sent me a message on, I think it was Monday afternoon. Passed away unexpectedly in the morning. So there you are. Very nice of Carmen to inform me, but really sad news, and Chris will be missed a lot. He was always in the chat here. He was always sending me stuff. I was sending him stuff. He was messaging me privately as well, and having a good old chat and a laugh. So yeah, we will miss him. So in Chris's honour, we are going to have a minute's silence. So, in fact, I'll stick my my starting soon slide back on, and we'll have I'll count it down to a minute. So I'll catch you in a bit if I can find the right button. Right, hopefully we're back and I've got audio. So yeah, sad news, but yeah, he will be sadly missed, oh Chris. But, if I get any more news, I will let you know. I think I've got everything back. Let me just have a quick look. Let's check that. Yeah, not sure. Hopefully everything's working. So yeah, I haven't had a chance to do my channel of the day or the beer yet, but as you can see, we have got some beer here. So I'm gonna have to add this later, but we have got something a bit different. Look, we have got some truffle pud stout from Salt. Now I don't know, this came from Asda. I don't know where it's from. It says saltbeerfactory.co.uk, so let's look that up. Saltbeerfactory.co.uk. Right, let's go in. So, Salt, who are they? About? What story? The UNESCO village of our home in Saltaire. Where is Saltaire? Osset Brewery. contact us. See where they are. Hmm. Where to find us? Yeah, they're in Yorkshire and London apparently. So, wow. Specials and collabs, all beer. This is the one I've got. So there we are. Truffle Pud 8% stout. It's a strong old stuff, isn't it? Gooey ganache flavours. Dessert stout. Chocolate truffle in a glass. Caramel, espresso and vanilla. Wow. I can't wait to get this one down my neck, I can tell you. £4. To be fair, £4 isn't too bad for an 8% beer. Obviously, if you bought it in a pub, you'd be paying double that, if not more. So there you are. I will put that link in the description. I will pop it in the description. That, and we need to find our YouTube channel of the week, don't we? So this kit, let's have a talk about this kit now, because this is interesting. This came in from a chap in Canada, sent me it quite some time ago now. I'm trying to think what his name was. It was Patrick Jonas from Canada. Oh, Patrick Jones, Patrick Jones, all the way from Canada. Now this came to me years ago, 2021. I had this, so apologies to Patrick for taking so long. But let's get the overhead camera right, because I think the overhead camera is going to be in demand today. Let's get that in shot. Let's see if the overhead camera's working. Yay, it is, together with my glass. So why are we a bit drunk? So he actually sent it in an Altoid's tin. Anybody know what it is yet? Anybody know what's inside it? Because I need one of these. So I need to make one. Let me just get this beer open. Let me get the beer open. I actually got 4 of these, what do you call them? Are they microbreweries? Are they? I don't know, but there seems to be a lot of this craft beers. There's a lot of craft beers knocking about at the moment. I bought 4 of them on an offer from Asda. So if you want to know where to get this in the UK, it's Asda. I don't know if they export. Yeah, that's looking good, isn't it? It looks the same colour as it does on the screen. It's like a sort of orangey brown colour. Anyway. Ham Radio Elmer, shortwave listener, active antenna. The active antenna is in a separate container here. This is the active antenna. Oh, that is nice. Hell, I've got to try and get the very last drop of that out. I have to leave the can upside down in case I can get some more. Let's go to the overhead camera then and let's reveal what's inside here. Do you know what it is now? Do you know what it is now? Needs a bigger tin. Well, hang on, is that? I got all excited then. I thought that was a couple of my... Oh, there we go. More stuff trashed. I thought that was my enclosure then. I just glanced down there, but it's not. It's some battery holders. Oh well. I have got some enclosures somewhere, but I don't know where the hell they are at the moment. It could be a crystal checker. It is a crystal checker. Now, this is coming, as I say, from Patrick over in Canada. And what we need to do is we need to go to QRP me to download the instructions for this. Well, I've got them here because I've printed them out, but if you go to qrp.me, we can get it. He did send the instructions with it, and they're here somewhere, but I can't find them. But luckily, that website is still going. So it's qrpme.com, I believe. So yeah, here we are, qrpme.com. And what we want is the... where are we? Transmitter can, tuna can kits, mint tin kits. Here we go. The one we're looking for is this one. So if anybody wants one of these, you can buy it. And that's what it looks like finished. Pretty straightforward, really, isn't it? I'm not sure where you put the crystal. Do you put it on here? Interesting. So, instructions. It was built to test 243 crystal blanks we're grinding. Oh, do we touch the crystal to these plates then, do we? And it lights up to say it's good? Interesting. I did build a crystal checker a while back that actually let you check the frequency. Crystal grinding, is that a thing? Wow. It's found in the book by George Dobbs, look, G3RJV. So it's basically a pass-fail jobby. And that's the circuit of it. So assume that this is the two pads and you touch them on the pad, do you? Yeah, touching an unknown crystal's leads to the two plates will test the crystal. What's this then? Okay, there's more. So touching any number lies within the pads. Take a half-inch copper pipe cap and solder a piece of wire to it. A loose end solder. I'm confused. What? Okay, there's more to this than I thought. What is this copper cap thing all about then? You know, I've probably got a 22mm copper cap. Oh, 15mm. Solder a single piece of wire to it. On the loose end of the wire, solder a single female header receptacle for a 0.25 post. Scrape the solder mass from the underside of the hole between the H and E above the rectangular pad. Get a tube of BBs, steel or lead shot and perform the following procedure. Ball bearings, steel or lead shot. I haven't got any of that. I should have called the frequency. Add shot to the pipe material current, same as the untouched crystal. Grind a little bit off the crystal. Whoa. Well, I think what I've got is I've got a crystal that I think is gone, so I don't think we need to do this. I can just touch the leads on this and it will light the lights if it's good. So we've got two LEDs by the looks of it. Fairly straightforward little thing to build. Now the other thing we've got is the active antenna, and I've really been looking forward to getting this one done. I don't know that I'm going to be able to finish this today, because I would like to build it properly, but I can show you the ideas I've got for it. Just trying to find the website. It's not got it, has it? There's a little card that came with it that I scanned the QR code on it, and it opened it up. Let's see if I can. I'm sure I saved it. I'm sure I saved it somewhere. Yeah, there. So it's in my cloud. Let me just find that a minute then. What are we on at the moment? We're on just me with my lovely red top. So bright. Now, where did I put this? I've been messing around this morning with one of my scanners as well, my AOR DV10. Those of you that are into listing on all sorts of bands will know about that. It's a phenomenal bit of kit, but mega complex. Now, have I put it where I should have done in here? No. Where have I saved it to then? Saved it to desktop. Documents. Oh, where have I saved it? Radio info. I think I saved it too. No, it's DB10. SD card formatter. Gowers. JPEG file. Okay. I should be able to get it off of this phone anyway. This IP35. Mini whip. Pardo mini whip, Kiwi SDR. It's not the same one. That's not it. Tech Minds has got a video on it. Powered by a bias T. Is it this one? There's lots of different versions of this. There's lots of different versions of this. Where the hell have I saved that to? Where have I saved that to? That I've actually scanned the card that came with it. I'm gonna have to go and get the card. Typical, it's downstairs, isn't it? It's downstairs. But I'll leave the schematic up for you there underneath the camera so you can have a little nose at it. Let's have a look at the overhead camera. That's probably going to be way too big. Oh, there you are. That's the schematics for the aerial. Let me go and get the little card. I won't be a second. Okay, I've got my little card now. So, Amy, you might be able to scan this off of the screen. How about that? That's the QR code. If you scan your screens now, you should be able to download that. Let me go to this tiny URL then, because I can't scan a barcode on the desktop. tinyurl.com /IP35MW. Okay. didn't work. Oh, tinyurl.com IP35MW. It certainly works on my phone anyway, I can tell you that. It's in. Where is it? Is it just in here? Signal tracer, operating manual. I normally save everything into this, but for some reason it won't do it. Maybe I've got to put the HTTPS in front of it. Yes. 2 little dots. Oh, always got the wrong one. 2 little dots // That link doesn't work. Strange. Okay. How do we get that up, I wonder? Can I access my camera from here or put it up in front of one of the cameras? I don't know. There's nothing on the back, is there? I don't suppose I can do it from that, can I? Hey! Thank you very much, JJ. It's on the Internet Archive. Archive? Is it? Well, you think I'd be able to scan that, wouldn't you, being it's on the screen? Location, location, location. Yeah, I've got a good place for this one, Baz. I've got a good place for this. Hi Martin, how you doing, mate? I was just saying I was going to do your radio cassette today, but I'm not feeling too special, so it's Ionosphere. How are you doing? You've purchased a nice project box from Waytech Components in Dorset. Yeah, I'm just trying to work out then how we can do this. I'm going to have to stick these sheets underneath the screen or something. But they've got various pictures of project boxes, etc. These pages don't seem to be in any sort of order. 7, 6, 5. Then we've got this one, which isn't numbered. No, that's the other one. And we've got number 12, final assembly. Ah, okay. So this is what we're going for. So we've got. I didn't know whether I could use 75 ohm cable for this, but I have now actually managed to find some 50 ohm. So we've got the antenna is this big bit here. This is the bias T, and this is going to be our receiver. It's really saturated, this camera as well. I don't know, it might be my screen actually, so it might not be as bad as it looks to me. We need Nix Pro for spectrum analysis, and Alex has sent me an oscilloscope, believe it or not. I haven't done the news bit, have I? Alex has sent me out an oscilloscope. Alright, catch you soon, Martin. I have managed to get a pinch roller for it though, Martin, and Deck Tech have sent me some belts to try, so we are looking good. And I've made some upstands. I've made the rebuilt the pillars out of epoxy. So I need to mount this in some sort of waterproof enclosure outside. Now I had an idea to put it inside a pill bottle, but I think I've got my dimensions wrong, because this is the actual mini whip antenna. I thought this was the bias T and this bit was the antenna. So I got myself a little pot that bit will go in quite nicely. So I've got to thank John Turner for sending this on to me. That's cracking. Really good. Now I don't know where the hell this document's gone. I really need to get it up on screen if I can. Where would it have put it? Would it put it in downloads? Desktop maybe? He loves to chuck stuff in desktop. Armory crate, curve bug. Unconfirmed. Yeah, I don't know what that is. Screenshot. Documents. If I can find it, I can pull it up on the computer, you see. List, sort by, modified, just to odors, test. Photos empty, stream in 2025. Did I put it in the wrong year? No. Huh. Bizarre. Share, send to PC. Oh, I'm disconnected. That's because I haven't got I disconnected the thingamajigger. Okay, let's try sharing it another way then. Let's share it to OneDrive. Let's put it in radio info. Let's try that. Radio info. Yes, we're in. We are in. Oh, that took some doing, didn't it? Whoa, dear oh dear. Okay, so frequency range 10 kilohertz to 30 megs, so HF only, which is what I'd use it for, to be fair. Apparently these are supposed to be really good on medium wave and long wave. I'm not so sure on HF, but apparently medium wave and long wave, they're very good. Now, I used to know what this stuff here meant, but yeah, I don't know. It's basically the way that they determine the quality of the receiver, I believe. So it's a PA0 RDT design. So it's best in class components, high IP3 transistors, noise suppression, ferrite beads and NP0 capacitors. So waterproof enclosure. I was going to use a plastic sort of like pill bottle to stick this in. Thermal and reverse polarity protection. Space for an additional ESD protection device. Now the problem with this, I believe, is if you add this in, it doesn't do it any favours. You'll knock a few dB off of the signal by putting that in, although there is. So I'm not sure about thermal protection. What thermal protection do we need? Not sure. So into presence of strong signals, the higher IP3, the more you'll hear strong signals. This is the intercept point, isn't it? Which is the one up here. The third one, isn't it? IP3, 35 dBm. So I'll catch up with the chat in a minute. Those of you that know will know. So we achieve 38 dB at 10 megs with 1 kilohertz space signals in laboratory tests. Sounds good, doesn't it? 9 to 14 volt power supply or a 9 volt battery. Again, I believe the bigger the power supply, the better it works. I'm not sure. Wear ESD protective wrist strap. Ah, okay. I haven't got one of those on. I've got one, but I haven't got it on. So it matches a popular 50 by 25 by 25 enclosure available on eBay. This is the bias tee, is it? Yeah. So that's this board here. Oh, that looks quite smart in that, actually, doesn't it? You've got to poke a power supply out of it somewhere, though, haven't you? Yeah. So yeah, that's the bias T, RX antenna. I think there's quite a lot of instructions on how to put it all together. My idea on this is to actually pot it in some potting compound. I don't think that'll hurt it. I don't think there's any components on there that are likely to get hot. We got a couple transistor packages in there, but Q1 and Q2, where are they? Looks like a FET. Q1's a FET, Q2's a... Yeah, they shouldn't get hot, should they? So we've got ESD optional, size 603. So I could potentially stick it's a diode package in there, couldn't I? I have got a diode package I could pop in there for a bit of static protection. I've not found them to be a problem. So it says you can solder additional copper wire or rod to the pad on top of the antenna area if you want to increase sensitivity. You may consider this. It doesn't say what sort of length though, does it? So there's a couple of these things here. So this is it here, is it? DigiKey, 46 pence. What is that then? Little fuse? TVS diodes. I see, so it's a single package. Where's the space then for the 603 device? Ah, there. Yeah. Not sure. But he does say something there that it dramatically reduces the IP3 and sensitivity by at least a few dBs. So, yeah. Install the antenna on a non-metallic mast or rod as far from buildings and as high as possible. So I've got a pole that my weather station is mounted on the shed. So I was just gonna get some clamps and not to do it permanently, but just clamp it. I reckon I can probably get that above the house if I got enough coax to do it. Yeah, so 12 volts gives the best results. Quality power supply or a 9-volt battery, so probably maybe a CB radio power supply. They're 13.8, so very close to the 14-volt max. What we don't want to do is encapsulate this in some potting compound and then pop anything on it. I mean, it's tough, isn't it? Because really it probably does want that ESD device in it, just to be on the safe side. But do you want to lose, what's the point of putting something up and then losing a few dBs of signal from it, as it dramatically reduces the IP3? Yeah. Do you feel lucky? Feeling lucky, ESD? Anyway, that's the situation. That is the situation. At least we got it up on screen. That's the main thing. Thanks, JJ. Gavin, how you doing, mate? Scorcho, flipping is, isn't it? You can fire 63 watts into that circuit, it'll be fine. Oh, don't know. I wouldn't want to put 63 watts through it, Baz. Aaron, how you doing? Modern version of Heathkit circuit. Let's catch up. Let us catch up. Be infused grease. Not ideal. Never name a folder miscellaneous. Oh, Alex is now Ionis. It is you, Alex. Well done, mate. You're just trying to confuse me. I suppose the A should have given it away. But yeah, thanks for the scope, mate. That's a lovely bit of kit. I've not plugged it in yet. 0 to 30, Gavin. 0 to 30, mate. Let's get the specs back up for you. Page 1. There you go, going. 10 kilohertz to 30 megs. So HF only, but long wave, medium wave. Apparently it's very good down there. Bob reckons it'll outperform my long wire, which I want to try. So it says I can use 14 volts, so I can use the 13.8 volt power supply. I might be able to wind the power of one of the CB power supplies down a bit. I'm not sure if any of them have got some little resistor presets in them that I can wind it back with. I don't know. So yeah, apparently we need static stuff. We need a wristband for this. Naughty boy, Graham. That's why it came in an anti-static bag, didn't it? No touchy. Right, anti-static. Let's get this this crystal checker built first, then. Now, I did come across my PCB holder earlier when I was searching for stuff. In amongst all this junk up here, I found my PCB holder for soldering kits like this that Andrew Alsford got me. But I can't remember where it is now, and I ain't pulling all that lot back out again. See, I thought it might have been in my tool bag. Anyway, we're going to go with this. We're going to build this one first because I've got a crystal that I need to check. So this is the crystal checker from our friends in Canada. So if you want to look, if you want to follow along with that, I did put that up on the screen just now, but I will quickly grab you the link. quickly. What's going on today with you, Graham? Quickly. So there you go. If you want to follow along with this, that's the instructions for it. Probably not in any order here again. I've shuffled it all up. That's page 1. Crystal grinding. What is crystal grinding? The ball bearing thing, it really confuses me, but so it says there are only 14 components and all the things are screened on the board right where they are to be installed. So, you know, what could go wrong? Everything is here. Everything is in this little bag. So I'm gonna have to get me me resistor ready reckoner out quick so as I know what the hell's going on there. So get me little resistor chart out. I've got that one as well. So let's have a look. So we usually put the smallest components in first. We've got a little tiny baby capacitor. I can't even see these things. What's going on here? What is that? 151J? Oh, this is going to be fun, isn't it? Right, let's put these little things in here first then. What is 151J? That's got to be a capacitor. No, maybe not. I literally can't see this. It's so small. This is madness. I'm going to have to get the microscope out just to see what this is. I don't believe it. I don't believe it. Right. Microscope. Let's connect the microscope because it ain't connected. Here we are. Okay, so let's get down a little bit. See what the hell this says. 151J. What is that in new money? 151J. What is that? What is a 151J? Let's just see if I can focus that. $150 picofarads, Aaron, is it? $150 picofarads, so are we going in the 150 slot then? We've only got one though, haven't we? We've only got one 150 slot, but two capacitors. So we've got a green and a red LED. Okay, that's green and red. It doesn't say which way round they go though. Yeah, so we got, I believe this is our green one. Doesn't say which way round it goes. So I need to refer to the schematic for that. Which I can't find. Good old Rex. Good old Rex. Rex the crystal grinder. Here we go. So looking at the schematic, if I can get the right way up, is that the right way up? Yeah, just turn that off. So the orientation of those. This is going to catch me out because I can never work this out. Whoa, it's hot up here. I believe the long leg is going to the positive side and the short leg goes to ground. Or in this case, for the green one, the short leg goes to the collector of Q2. So, where is Q2? There. Okay, so we've got a problem straight away because that doesn't appear to be connected to that one. So collector of Q2 is there. That should be connected to the green LED. So collector doesn't connect to either of those. Does Q1 though? That clearly says Q2 though. This is interesting then. So is this Q1? And this is Q2? So the emitter of Q1 should be connected to our 1000 puff. Okay, it does seem to be. Or is it that one? Which 1000 puff? Because we got two according to that. This is not going to be easy, is it? That doesn't seem to equate right. Have we got the wrong diagram for this board? Can't be. So according to my board, I've got 2.001s. Ah, there's the other one there. Okay, right. I'm going to stop populating it, and then we'll worry about the diodes in a minute, because I think they might have got the screen print wrong on that. I hope not. So what have we got here? 47. So we said these are the 150s, didn't we? I'm getting all these mixed up here. I've got the what's names in with the what's-its and the what's names what's-its in with the what's names. It might be easier for me to see that picture online because it's printed out shockingly bad for me. Okay. I don't know why that printed out so bad, really. Ah, we've got another picture. Okay, so we've got another picture which I didn't see before. So according to the schematic, green is supposed to go to the collector of Q2. Well, the collector of Q2 only goes to the 220. So it goes through the 220 into the green. In the schematic it shows the 220 before the green LED, not after it. So that's the difference then. Oh, I see, and they've got the little stripe there to show what the cathode is. Okay, let's print that one out then. Let's print that one out in colour. Let's print that. Where's it going? Yeah, okay. That helps a little bit. So the little stripe, is that the long leg or the short leg of the diode? I believe that's the long leg of the diode. It's normally denoted by the little shaved off bit on the base, isn't it? But I need to find out which way round diodes are. That's what I need to do to start with. That's what I need to do to start with. Because most diodes have got like a flat piece which indicates it's like the cathode or the anode. I can really get confused about diodes. It's like it's not OCD, it's what do you call it? Just mental. You just can't quite see from the picture which way round they are. But I think that one is showing the flat on the left. So that gives us a good idea of how we're supposed to build it. We're not doing well to start with here, are we? We're not doing well to start with. So let's get building. Let me make sure you can see what I'm up to here. Let's get that one under there. So we need to be there. That light is a bit all over the shop. That's probably better for you there. Let's do these two diodes first then. Flat side of LED envelope is negative. Connect it to diode mode. All good suggestions, thank you. So our first diode goes in there. The other diode goes over there. Four 1/4/8 small signal diodes. I'm going to solder these in as we go. Otherwise, it gets a little bit too busy. That's my beer gone as well, which is a bit of a disappointment because I don't believe I've got any more beer. Oh, wrong LED. What tip have we got in? Yeah, we've got the right tip in. So it's a brand new board, so we shouldn't need any flux or anything with this. We just use the flux that's in the solder. It is a double-sided board, so you need to make sure the solder's flowed through, which it has. Nice. Snippy snip snip. Legs off. Get off. Okay. So what we're going to put in next then? Let's go in with the diddly little capacitors next then. I've got a little leg bender for these, but I don't know where it is at the moment. A little stepped thing. Would have been nicer to bend the legs exactly to the right size. Get everything nice and neat, you know what I'm like. That's that one. And the other one goes in underneath there. 0.001s. Oh, is that right? Yeah. Well, that said 1.5. Yeah. Well, that's how they got it in the picture anyway. Let's solder those in. I'm looking at this picture here, look. So that's what I'm looking at. And they're in that place, so that's where they're going. But I'm not convinced about... Yes, yeah, Q1 and Q2, they've just done it differently. They've put the resistor after, so the schematic is different than the final layout of the board. Just to confuse the hell out of me. But sussed it in the end. You know what it's like. So again, make sure that they've soldered through. Yeah, they have. Snip those off. And that one's not soldered. I haven't even soldered that one yet. Would help. Would help, wouldn't it? Right, what's going in next then? We've got our 1K resistor, which is brown, black, red. In fact, it's a lot of 1K resistors, I think, so we're not going to be too worried about that. I say a lot. We've got two, but then we've got conflicting information again. What is going on with this? This is strange. So I don't know if Patrick's watching this. He's probably thinking, what the hell is that bloke doing? What is he doing to that kit that I let him have? I gave away a lot of the kits that Patrick sent me. I gave them away on the Christmas live streams. Okay. I kept a couple for myself. I kept this one, and I think there's one more which is a QRP transceiver, just for Morse, which I thought I'd have a go at that. Okay, let's do the rest of the resistors then, because I've got some. Okay, no, that is red, red, brown. That top one, which is 220. But there seems to be a little bit of a discrepancy here. Let me get that that board layout off the printer. Yeah, there should be two 220 ohm resistors, which is, where's my little pointery thing? That'll do. 220 and a 220 there. Well, I've only got another 1K, so I need another 220 to go in there. So it's the wrong resistor, which I seem to find a bit confusing. Let's see, we've got another 220. That's going to be one of these, isn't it? Hunting around. 220K. We don't want 220K, we want 220 ohm. 7K. No, hang on a minute. Alex sent me a load, didn't he? Alex sent me all these. All of these. Look, have we got 220? Come on, Alex. Let's have it. We got 220. Come on. 22, 139, 47, 120, 220. Yes, well done, Alex. Ooh. Nice. See, they've come in useful already, Alex. Slightly lower rating, but then we're not putting much power through this, are we? Right. That's strange they've sent the wrong resistor, isn't it? But then maybe Patrick sent these over and made up the component kit himself. Luckily we can follow schematics roughly. Where's old Rob Cross today anyway? Where's he gone to now? He is like Lord Lucan. Where's our Irish friend gone to today? Okay. So thank you again, Alex, for sending those over. I wonder if there's any way we can measure on this board the frequency, because we're putting the crystal under test, so somewhere we should be able to measure the frequency of it, surely. Coming on nicely. Right, so our other resistor is this one, which is orange, 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 orange. Orange, orange, orange. 33K. Yes. Going underneath that one. It looks like I've soldered over the hole, which is really nice of me. Let's just undo that. 33K. And we will be testing some crystals in a bit. I have quite a few crystals knocking about. Sadly, still no 21.5 though. Still after the elusive 21.5 meg crystal. Anybody has one? Would be nice. Just touch that one in because I cut the solder back a bit fine on that. Going well. Right, what are we going to put in next then? What's our next smallest component? Let's put these ceramic caps in. What are these then? We've got 47. We have a 680. So we know the 680 goes in there. Can we make these look pretty? Probably not. 680, 47. Again, I've soldered over the hole there because it's quite close to that other one. Steady, come on. Very pretty, but they, they stand up a bit. 150. Try and make it the same height as the other ones. Right, what have we got here? So we've got our two transistors. Well, one is a transistor and one is a FET, I believe. So Q1. Oh, it's saying that saying they're both the same on the schematic, on the thing, and I believe they are the same. Yeah, they're both the same. Well, the perhaps I'm looking at I'm getting confused with the other one online. So these are 2N 2222A. 2222A. One. 2222A. Or is this just back? Thank you again, Alex. Saved my day. Saved my bacon. Saved the day. Come on. I'm going to flow a bit more solder into those because for some reason I decided to be skimpy with that. Should be better. Right, looks like just our 2 LEDs left. So I believe the flat goes to the stripy bit. Look at that. So we'll know if they're the wrong way around because it won't work. There's one, and let's do the other one. So we want the flat bit going to the stripe. So the schematic is slightly different to the board layout, but same sort of principle. Okay. We've got some jumpers. Got a jumper to go in there. be a little bit of a pain to solder. Let's solder one first. Oh, gotta wait for it to go off. So EXT, I'm not sure what that is. EXT. That one is actually spot on. Good deal. So J2, I'm not sure what J2 is all about either. Or is that the one? Yeah, I'm not sure. They've not got J2 populated on this board. So it looks like they're using these as strains for the 9 volt. So it looks like we're going down through there. That's quite a good little strain relief, really, isn't that? Good little idea. Come on. Okay. Didn't seem to solder that well, did it? Definitely in there. Black one needs to go through a little bit further. Better. There we are. So it looks like there's a little power jack there that could be soldered in, I suppose, in place of this one somehow. But basically they're using this as an on-off switch by the looks of it. So that is on there with this little jumper and off there. Okay, well, I think we are ready. They've even given us a little test crystal, I believe. So let's give it a go, shall we? Sharpie, how are you, mate? Danish, how are you doing, mate? Dual purpose crystal checker and a puzzle. I'm a bit lightheaded there. Let's get up out of the way. Right, let's get some stuff off the bench. Ow. Keep jabbing legs of stuff. Let's put that way around. So say they have given us a little crystal there. We've got a battery. So I think we just touch the crystal gets there, and if I know we got power there. Oh, that's just a power. Ah, that's just a power LED. Turn it the other way around. Yes, okay, interesting. It works. Clever, isn't it? I assume you can put a little battery holder in there. That's what the solder tabs are for, I expect. You can put an SMD PP3 holder in there or something. I'm not sure what J2 is. There's some weird thing they're using with a 15mm copper cap and a wire and things, and I'm not sure what EXT does. Can we test this? Can we test this with a scope or anything? I don't know. Let's get where are we? Let's get the crystal out of this board that I think the crystal's gone in. Nice. So let's just turn that off a minute. This is the board from a, what is it? It is the VHF converter unit. I think it's FC20 or FC10 for the Kenwood R2000. So it's a VHF converter, but I've got a problem in that this oscillator has died. So when I was setting up to do the adjustment on this, basically you've got to put a scope. You've got to attach a scope to this test point here. This little white upright. You attach your scope there, measure the waveform, and then you peak it with these two. Well, this one is inside a can. So what I did, in my wisdom, was left my scope attached with the power. I then got a screwdriver underneath and I popped this cover off. It's got like just a flat cover that goes over the top of that, which you probably heard fall on the floor just now. Well, that, I believe, has killed that crystal there absolutely dead. I might be wrong. It might have done one of these transistors, but this is not oscillating anymore. I should be able to see the frequency of the crystal on that test point, but I can't. I couldn't see any better with a light. So what I've got to do is take this crystal out and we'll test it on this tester. That will tell us yes or no whether it is that crystal or there's something else in that circuit that's a problem. So this is the whole point of building this little kit, is to test that crystal. You're dead crystal, that's what we're hoping for, Sharpie. Well, we're not. I'm hoping that it's good. That the crystal isn't dead and we've got something that's replaceable, because I cannot get a 21.5 meg crystal anywhere on the planet. I did have a chap that sent me some close ones. So I'm just firing up the old quacker. And I'm going to try and take that one out. Is there a shield? Yeah, of course there's a shield underneath it. Huh? Right, you notice I've got a long reach tip on here now. This is a 1.3mm, much better. The 1.6 was too big and the 1 is too small, so 1.3 seems to be the way to go. Right, now where is this crystal? It is here. I think it's across this one. I think it's there where my finger is. Gotta be really quick on these because desoldering can kill your crystal as well. So this is going to be a yes/no test of this crystal. Put that board to one side. Let's have a look. Sure enough, yeah, we are definitely a 21.5 meg crystal. That. What a rare beast that is. Can't get one anywhere, but I reckon that's what I've killed. So let's get Johnny the crystal tester in. See what he got to say. Yes or no? Good or bad? Please let it be good. Whoa! No way! Whoa, does that mean that actually... Ooh, interesting. Okay. That is interesting. That is interesting. Are we saying that that crystal... I don't know. How are we going to know? How are we going to know whether that is 100%? Is this thing okay? Is it working right? I don't know, but I'm going toilet. Be right back. I'll see if I can get someone else to drink in the meantime. You thought it would be okay, Nick, did you? Okay, so this is interesting. Are we confident that this is measuring right? It needs a frequency counter output. How would we get a frequency counter output from it then? How would we measure? Oh dear. So where can we measure the frequency that this is oscillating at? Have I been trying to find a crystal all this time for no reason? I was convinced because I gave it a fair old whack, you know. And it was working. It was a bit deaf, but it was working prior to me doing that, and I did have a good waveform. Oh, it's got a frequency counter there, look. That's interesting. Where is that to then? That's on the measuring of the diode and the 47 picofarad. Okay, so it appears that we can connect to the 47 picofarad to read the frequency out. Frequency counter. Surely a scope would be the same, wouldn't it? Can we put a scope there, or does it need to be a frequency counter? 47 picofarad. The other problem is getting the crystal actually attached to there, isn't it? Yeah. So it looks to me like the EXT is measuring the collector of Q2. That's connected to the EXT socket, one side of it. The other side is connected to the 47. What's the middle of it connected to? And the middle of it's connected to that weird pin. So they've not got the EXT printed on here, so this must have been an earlier one. This one here is certainly on there. That hole, which it looks like you can, it's on about joining that up underneath, isn't it? You need to reread that then potentially. So yeah, this is a different revision, this, so certainly this side of C47 has got its own track now. That's why the 47 NF that's got its own track now that comes down here. This one goes to the center. What we need to do is look at the yeah, this is not making sense to me. So it lies in the two large pads. A large square pad is the active side of the crystal circuit, with a smaller rectangular is connected to the ground plane. Touching an unknown crystals will test the crystal. Are you on this page with me at the moment? Yes, you are. So the secret to grinding your own crystals lies with the pads. Now this is a bit nonsense. I don't understand this. So they're putting a copper pipe cap soldering a piece of wire to it. On the loose end of the wire, solder on a single female header receptacle. Oh yeah, that's that. Scrape the solder mask from the underside of the hole. Solder in a wire, rat pin or any other post. Now you can clip the 1/2-inch pipe cap lead to the post. Yeah, okay, what does that do? Then there's something about getting a BB's. Turn my desoldering tool off and solder it on for a minute. So the EXT connectors have sending the oscillator output to a frequency count. The top pin is the crystal frequency, while the center pin is ground. Okay. Top pin is the crystal frequency, while the center pin is ground. But let me get back to the top one here, so you can see that we've got 3 connections to this. And the ground, I don't think the ground is connected. Or is it? I'm confused. Well, I think we're about there, aren't we? So let's go in a bit closer and have a look at this board a minute. Let me get my thing down so I don't have to use the optical, what's his name, zoom, the digital zoom. So we see the EXT. Where's my pointer or anything? So this pin here connects to the capacitor Mark 47. This pin goes to the collector of this transistor, also over to this resistor here. The ground is the center. Okay, so it's not connected on the top of the ground, but if you look underneath, the ground is connected to here. Oh, hang on. No, that is connected to ground, isn't it? Of course it is. I thought, because they were on about grinding that out and putting a pin in there, weren't they? But we don't need to. All we need to do is rest our we need to just rest our crystal across this and then connect our scope between there and there, and we should be able to measure. I don't know what the third one's for. Yeah. Yeah, okay. Let's get physical then. Should we use the scope or frequency counter? Let's use the frequency counter, because it's easier to see for you. It's easier to see. Pardon me. Plus I can leave it connected up. If I can find my PNC connector, which I use this one. It's really handy for that. Could have connected Alex's scope across it. We might still be able to, but we've got other stuff to do. So up to 125 megs. Gonna get the other camera in for this. Are we gonna be able to connect this up? These clips are a bit big. That's a positive. That's the ground. I need to bend that one over a little bit, I think. Stop them shorting. Okay. Let's see if this is indeed oscillating at 21.5 megs. Wow. According to that, it is. I mean, I've got my fingers on it, so it's changing around a bit. Let me just put the filter on there a minute. No, it doesn't like the filter. I'm trying to get it so as I can get 14.34. It should be 21.5. Okay, let's just double check that against this one then. So what's the frequency of this one? This is 3.6864. 3.6864. Yeah. Yeah, I've got a knackered crystal, haven't I? Because that is reading 3.686. What other crystals have we got? I've got loads of crystals knocking about here somewhere. Which box are they in? Ow. I think they're in this one. Yes, okay. I'll tell you what I haven't done, so I haven't checked this box to see if I've actually got a 21.5 meg crystal. You never know. So let's chuck a couple of these random crystals on. What have I got here? This one says 1024 CVS, whatever that means. What? 20.47? That's close, isn't it? That's scarily close. We've got one that says 6 dead. 6 meg. Yep. What's that one? 8.867. Yep. So let's get some CB ones, 10.24. Oh. Seems to be doubling them, doesn't it? 20.4750. What's going on? Derek sent me an email. Overtones. Check my email. Stick a scope on it. So it looks like there's some weird anomaly with the larger crystals. What's this one? Another 10.24. Yeah, 20.4. What other random ones have we got in here? More sixes. What's that one? I don't know what that one is. 6.24. Derek sent me an email. Let's have a look at the email. What's going on here? I can't get at it, Derek. Oh, the phone's doing some weird stuff now. Now, didn't I try and get one of these? Thank you, Derek. Derek's found me a 21.5 meg crystal. Through hole. Yeah, we looked at this the other week, Derek. I can't get that bloody thing off. It's not available, unfortunately. We did look at it, I think, a week or so ago. It's not available. So the simple crystal circuit can't handle overtones. I wonder what happens if we put the ground on that end one, but that's probably going to short it out, I expect. Yeah, I better risk that. So, Vaz thinks my crystal is good. And it's reading 7.17 then. What? Let's get the. It's reading 7.17 then. And with the filter on, it's reading 50. Whoa, weird. We've gone into another dimension here. Now my box with all my crystals in won't shut. Seven 7.17 times 3 is 21.5. Oh, wow. So look at it with scope as well. Should have got Alex's scope out really, but it's a bit it needs a bit of real estate. I need to stick it in with my other scopes over there. Okay. That's a bit noisy, isn't it? But 3.68, you can see the frequency down in the corner there. You probably can't actually. Let me just zoom you in a bit onto the front of the scope. So this is the test one at 3.6864 should be. Probably my fingers are messing with it a little bit. Can't hold it on there properly. And let's put our one from our VHF converter on there, see what that does. Should be on ×1 maybe. Definitely working, isn't it? Oh, interesting. What the hell could be wrong with it then? So you think that's is it a third overtone they call that? I don't know. But that's a handy little tool, isn't it? It presents too much parallel capacitance to get the overtones to show correctly. Okay, let's go one stage further and look at the circuit then for the FC10, I believe it is. C-10. No. Let's cut some of these pages down. Now, somewhere in here I've got the Kenwood R2000 VC10 service manual. Okay. So, let me show you where I was on the alignment. I was going through this methodically, doing the alignments. Now, where were we? Block diagram. So I've gone through these. I've done the voltage checks. I've done the first local. Now this is where I got to. Connect up to test point 8. So alignment T42, T44 and TC4, and maximum amplitude at 21.5 megs. Replace the top covers to the shielded HET case. So I had that till I popped the lid off and then it died. So either I've shorted something and killed something, or that crystal had died. Now I thought the crystal had died because it did have a fair old whack and I had the power on at the time. This is a very good schematic, by the way. So, second. Now, where the hell was the third? Yeah, here we are. So I was connected to test point 8. My alignment was to just those two, plus this trimmer cap back here. So I had my scope attached to test point 8, and I was measuring my 21.5 meg crystal, and it had a nice waveform on it till I popped the lid and then it died. So what would have caused that to die if it's not that? It could be one of these, couldn't it? Q24 or Q25. Or it could be any of the components in there. Have I inadvertently shorted something to the can? It's difficult to hook it up because I need the R2000 to hook it up, and that's over on the bench over there, all wired up. Not impossible. What else is likely to have failed in that? I mean, if I've shorted something here, it's going to be one of those transistors that has gone, surely. It's not likely to have taken out capacitors or anything like that. Let's go back to the chat and see what you think. Oh, I've got stuff up in my face now. I got another mail, Martin, did I? If you used a spectrum analyzer, you would see a harmonic at 21.5. Interesting, Danish. I could connect that up somehow. So Martin sent me an email now. Let's have a look. Emails. No, Martin. No email as yet, unless you sent me a WhatsApp or something else. You got another email, Graham? I can't see it, Martin. Yeah, it's not come through, mate. At the moment. It might do in a minute. L17 may have acted as a fuse. They certainly are, Alex. L17 may have acted as a fuse. Wow. You can certainly check L17. You can certainly check L17. Which I think is there. Oh. Yeah, 1.2 ohms. So L17 looks to be okay. That's that one there. Difficult to get in here to measure it. Q25 is there. And Q24 is there. Can we see them on this side of the board though? I think it's those three. Let's check it on diode test. I think it's over here. What is it there? What was that? No, it is. It is there. It is this one. Yeah, there are no shorts on those, not to say they're no good. So L17, I'm pretty sure it's that one. It's difficult to see because it's so strangulated in the case here. Yeah, that one is showing continuity. So it looks like those two are checking out. I'd have to take them out of circuit to see for sure. That seems to be okay. Transformer there, potentially. I mean, as I say, I priced it to start with here. Then I went across here and priced it. it needs a lot of signals from the radio in order to work. There's a lot of connectors come out from the radio. There's a whacking great DIN plug there with loads of different connectors in it. Bit grubby, mind you, but yeah. Transistors are sensitive. It's still crossing the channel. So it also has a 21 to 21.5. Still no email. Still no email, Martin. No. Someone sent me some diodes. Diodes? What are you banging on about now? Some crystals. Baz points out about failing transfo DC volts. Okay. So the transformer is in here. You can just see that like ring there. Ring, ring, ring. Where are we here? That's the transformer. Now I don't know what the pinout is on it. Normally that's the input side. That's a short. That's open. That's a short, 28 ohms. So I've got 28 ohms, 0.28 ohms there. And 0.28 there. That can't be right though, can it? What's the point of that? Because they're connected together if it's going that way, and they're connected together if it's going that way. How is that wired up? Hey. Yeah, it could be. It could be a number of things, but I mean, let's get Mick the microscope in. Let's get Mick the microscoper in and have a look. Let's turn this around so I can see it a bit better. So where are we? Better. So this is the little transformer that's in there. Don't appear to have anything there dodgy legged. This is obviously where I've taken my crystal out of. just where I've done that. Why have we got a little shard here then? Is that see that little shard there? Is that short into there? Yeah, I've got a short there. But is that because that's connected to ground anyway? Just knock that off a minute. Sometimes emails appear in the spam. Yeah, but Martin's don't normally. No, nothing in the spam folder. Ah, I've got it. Yeah, I think that means it's just the 13-meter band crystal. You can't see it on there. Oh. I'm trying to show you the phone underneath the microscope. Madness. Yeah, I think that means it's just this 32.59 meg crystal for the 21.5 to 22 meg band. I think that's what that means, Martin. So look at the second one. Yeah, I think that's what it means. Wow, that's interesting. Oh no, still got a short. that is ground. Yeah, that is ground. So there must be something linking that out. So I can't see anything else untoward there. I mean, that's just where I just scratched that. So the test point is over this area here. This is the other area. So I resoldered the test point here just in case. A blob of solder there, but that's not doing anything. That's very close there, isn't it? I don't think it's touching, but it's close. Where did I prize it? I prized it here. There's lots of dodgy looking legs, and there's another one there that looks like it's touching. There's another one there. That. Is it just me? I doubt whether it is touching, but you know, it looks damn close to me. I suppose the other way to test, because I mean we could be measuring something weird in here with these transistors, is to pop them out. Have a look at them on the transistor analyzer. Let's do that. I mean, let's pop the old sucker on. Let's pop the old sucky suck on and get them out. Find the transistor tester, component analyzer, whatever it's called. Cheers, everybody! I've got some cider, some fruit cider that Mrs. Cruncher won in a raffle, and I think it's Liddell or Brothers Drinks in Shepton Mallet, Somerset. Brothers then. Maybe it's not Lidl's then. Colliders, or Collier's cider. Made in Somerset. I thought that was Lidl's, but it clearly isn't. Wow. What's that? I'm not sure, Aaron, to be honest. Aaron? Not Aaron. So that's the description on it. It is a 32.59, 21.5 to 22 megs, 13 meter short band crystal. I think that's the one that goes in to do that, isn't it? I'm not sure. I could drop him a message, but as I say, it sounds to me like we're saying that that crystal's all right. I know I made a little crystal tester circuit. But like I think Bob said, he put it on the spectrum analyzer might give us a better view. But can I connect the spectrum analyzer directly to that? Is it going to cause any damage? I don't know. Let's turn this suckery sucker on then. Sucky Sucksville. Let's get these two transistors out. Are they the same transistor though? I don't think they are they? Q24 and Q25. Where's our parts list? Don't tell me it's not going to tell us what Q24 and Q25 are. tell you what, this is, you struggle sometimes with these instructions. Transistor, so it doesn't say which ones they are, it just gives you a list of them. Q24, Q25, well, what are you? Doesn't say. It doesn't list what they are on the schematic either. Seems really bizarre, but it doesn't. It doesn't. Am I cracking up? It definitely doesn't. It lists the FETs in there. Oh, hang on. Yes, it does. It does. So what are we on? Q24, Q25. 2SC looks like 4604. Of course, I can't see what it says. But they are the same, which is what I was hoping. I will take them out one at a time though, and put them back in where they came out of. So, first one is there. Right. There's not really much else that could be wrong in there. Unless it's outside of there. HFE 93 NPN bijunction transistor. No problem. So it says, looks like it's 2SC480B. That's not going to work like that, Graham, is it? You know that. Why are you even trying it? What else would have killed my oscillator? Can't get the damn thing back in now. Oh. I think I actually switched cameras then and showed you the wrong thing, but yeah. See, they're saying it's a 2SC4. I can't even read what it says. So it's 460B. Let's get me head down. Cool. Right, that's in. Let's get the other one out. I think he is in there. I think. Seems to be moving much. Yeah, he is. Okay. Let's go overhead camera. Fine. 100 HFE, so one's 93, one's 100. Not much difference. Not the transistors. Get the damn thing back in again. So they did test out all right in circuit. What the hell else could be wrong in there then? Guess we have got a problem with the transformer, but let's solder those back in. What's killed my oscillator then? It's one of the other crystals gone somewhere else. See, the board is really well secured. It doesn't flex at all, really. So we've got two FETs in there, Q13 and Q14. I'm pretty sure I've checked those. So Q13, Q14, could they have caused the problem? Could I've not one of these cores loose? That one likely to cause a problem with the oscillator? Let's check this one. $28. 14, 15. Slightly lower resistance there, but not using the center tap anyway. Yeah, so we've got 28, 29, same as the other one there. This one's got 15. Could that be shorted? What's the probes reading? 0.08. No, so it's not shorted. I don't know. So certainly not the two transistors. Potentially it's not the crystal. Oh. I haven't checked the voltages around it, so I should do that really next, shouldn't I? So I need to check these voltages really, don't I? 5 and 7.4, 1.7 and 7.2, 1 volt on the emitter, 4.4 volts on that emitter. So I need to check those voltages maybe. You know, knocking it may have jarred one of these, killed the oscillator, I don't know. Where's this fed from then? It's fed from back here. Stripey comes back to Q13, Q14. That's the third mixer. So we've got a dBu figure there, look, 20 dBus. Nice. Anyway, we're deviating a little bit. Our little crystal tester is a go no go thing. I think we can measure it, but it doesn't measure the third order, is it, or third? What's his name? Third, what's his name? Well, I'll tell you what, it's getting blimmin' hot up here. Oh, B&M, Dave, is it? Hot doggos. So, what we're saying then, Nick is saying that's not what you're after. I think the crystal's good. What's not what I'm after, Nick? Oh, not the right one, yeah. Diagnose the overtone, harmonium. Yeah, definitely, Bob. As I say, I'd need to pull the pull it out of service. It's over there, connected up with all my other test gear. So the other thing we were going to look at, which we haven't really, is this. That'll light up out of the way. This very nice mini whip, which I was hoping to get underway today. It might be my little project for tomorrow. It's bank holiday tomorrow. I've finished one of Alex's amazing radios, but all is not well, Alex, if you're still with us. All is not well. It's working, but it's not working very well. It's not working very well. well, it works, but it's not very sensitive. It's deaf as far as I'm concerned. So something's amiss with that. I've changed the front end FET again for a different one, and that ain't made a lot of difference. That's my little tester. He should live in here. Where's my little tester gone? Wow, that's been beamed up already. How has that already been beamed up? It was literally here. It's not falling on the floor, is it? You see, it has. Well, it doesn't quite. So that's my little... I like that. That's a quick and easy go, no-go test, isn't it? So I must keep that in with the board. And I'll have to connect that back up and have a look through those voltages. See if I can find any discrepancies. Don't know where my little pot has gone for those. Oh, God, I'm sticking to the seat here. It's not very pleasant. So yes, what we're going to do with this then? I need to find something that'll fit into. Now, I know when John's done his, he's put it into some pipe. He's put it into a bit of pipe. But what I thought I would do was to get a box to fit it in and cable tie it to the fiberglass pole that I've got. Then I can sort of put it up and down as I need to. The potting compound I've got is this magic gel. I'm in too close, so close. I'm in so close. So this is the stuff I was going to pot it with. And it takes 5 minutes and it's ready to go. Goes off really quick. It's a 2-part one. I think I used that to fix John's, because we replaced the FET in his AN1, didn't we? Remember that? I've done some weird stuff on this channel in my time, haven't I? But yeah, this is going to have to get built, and sooner rather than later. I think I'm going to put the little wire on it. I've got some copper antenna wire, some hard copper wire, but I don't know how long to make that piece. Baz is saying you could just power up that stage with bench PSU and croc clips. I think the problem with that, Baz, has got so many different connections on the radio, I'm not sure which ones are which. It's really difficult to trace them back. I've tried tracing them back through the radio. It's a nightmare. So yeah, voltage checks next on that. So as for hooking this up then and getting this working, let me have another look at this layouts, etc. on this. There's so many bits of paper flying around now. So basically the little board here sits indoors next to the radio. with a short bit of coax to the receiver. Now the next thing is, what receiver do I put it on? Because I've been playing with my SDR, and that is really interesting. I've been downloading DAB, not downloading, but power supply's packed up on that now. I've got a little like multi-coupler which I bought cheap, and it does seem to be working, although it doesn't like my whistler. It doesn't like me putting the whistler on it. Let's just try. Let's go into antenna A with them. Let's just have a quick play with the SDR, because I think I'm probably going to use an SMA to BNC connector to run it. I do like a nice SDR receiver, although I prefer the analog ones, obviously, but you can just see so much with this. It's unbelievable. It's unbelievable. It's unbelievable. Okay. Let me just launch SDR Uno a minute. I know there's a lot of other SDR packages out there. I've only ever used SDR Uno because it's what I know. Let's hope it doesn't kill the stream. No SDR, no RSPs can be found. That's not good, is it? It didn't find it. Why didn't it find it? It might be because, I don't know, is it doing it because I'm streaming? No, it might be because I haven't got it plugged in properly. Let's try that again. Yay, now we're working. Okay. So I've got two antennas connected up to it. I've got my airband diamond aerial, which I don't rate at all. Have I got that, or is it the CB aerial I've got connected to it? Which ones have I got connected to it? Oh no, I've got the long wire. So I've got the long wire and my amateur VHF UHF aerial connected to it. So I can go screen cap. I can't see the chat though. I can't see the chat. Can I pin the chat? Will it let me pin the chat? It won't let me pop the chat out. Are we still with it, everybody? Because I'm going to show you what we're going to use this for now. But I can't see this unless I open another chat box. Outside of here. Right, let's have a look then. So antenna A is the let me have a think. Antenna A is VHF UHF. So I'm now in DAB, I believe. So I've got a DAB. Hehe, no. Where's me mute? volume. So you can basically decode DAB with this thing. Capital, DAB Plus, Planet Rock, Radio Wales for Gavin. I mean, there's so many you can download, but we don't want that. We want the airband, don't we? Let me have a think. Airband. Download plugins. Let me think. What's the airband? AM. No, am I on the right antenna? I'm on the wrong step size for this. I'm on 9 kilohertz steps. I'm sure 133.6 is the is one of the local ones to me, but it seems to be we've got everything but, doesn't it? Yeah, there's one there. That. The problem with airband is it pops up all over the place. You could clicking forever on this. There's quite a strong airband there. That. Hey, what's that? What channel's that on? It's popping up all over the place. Look. Strong one there. Data. You're forever clicking on these things to try and find one. Maybe we need to be 10 kilohertz steps, maybe. Come on. Okay, why can't I hear that? Is it below the squelch threshold? 133.7. There's airband signals all over the place here, look. Let's zoom in a little bit. Come on, give me one. Here we go. There's one there. Look. Come on, and again. No. That's one there now. Look. I tell you what, it's a nightmare now trying to find. We've got the wrong. I'm pretty sure 1336 is Brecon, which should be fine. Why can't I hear anything? Overload, it says. It's a hell of a signal there then. Well, let's switch to antenna C then. So let's go for HDR, medium wave. Now we need to be 9 kilohertz steps. Why am I? So I can get more on medium wave on this than I can on any of my other radios. So long wave. Currently there's
It seems as though everyone in the world is asking if poetry is really treasure or something more confusing.
That's wide signal as well. Look at the bandwidth on that.
Why is poetry hard to understand?
Look at the skirt on that. It's coming right out here.
Is poetry the good clothing brand? Poetry is the best words in the best order. Poetry is a waste of time. Poetry is a kind of lying. Poetry is not supposed to rhyme. That's Brian Bilston revealing the questions people are asking right now at this very moment. Brian's been dubbed Poet Laureate of Social
What have we got there? Isn't that some sort of time signal on 162? And 153, there's something there. But what a shame, isn't it? That's all that we've got.
Written by a mystic monk, poet and broadcaster on Radio 4 Extra down.
Yes.
Turns on the neon light for
I don't know what this is. NDBL, LFER, full. What's that?
The work of J.H.
Oh, okay.
Now, it's more than a decade since
So you can look at the handbands.
with a tweet that went viral, much to the surprise of a man
Now,
known as the Banksy of poetry.
what are we likely to get? We've got, say, 40 metre band. There should be something on that. We're going to need. Broadcast bands. 31 metre band, anything on there? Oh, lots. I mean, look at all the. Who said there's nothing on shortwave, lad? Synchronous AM. So it's a good little tool for DX, isn't it? .41 metre. No. It looks like a 25 metre band, 11 megs is mental. Look at all these signals. Let's change the step size. I mean, look at the bandwidth on that. China, isn't it? Anyway, I'm messing about. Let's get back to business. Let's shut that noise up. Hopefully, you were able to watch that. hopefully. Yeah, I think it can, Bob. You just need to know your step sizes, and I keep forgetting them. You know what it's like. Alex is saying 124.6. Yeah, so I've got an antenna coupler thing there, but I need to charge it up because it's got like a lithium battery in it. Martin's off. Catch you soon, Martin. Baz is saying at 25 and 8.33 for airband. Kim uses SDR-PP, SDR++. Joe's still there. So there's an interesting thing in it. That's an RSP, SDR Play, RSP DX. There's a bit of a mouthful in it. Steve, how you doing, mate? Sheffield Steve, that is. Volmat. I mean, Volmat would be mental on that thing, wouldn't it? I would think. I say, unfortunately, I can't see the chat. I could if I went here.
Homeowners with an electric direct debit of over £80 per month can now take advantage of the 2026 UK solar programme.
Pop out chat.
A limited number of homeowners brand new solar panels to cut their electricity costs to almost nothing. People just assume they have.
Oh, right, I can pop the chat outlet. Whee, okay. So we wanted Volmat, didn't we? Oh. No, let me think. I'll get over this thing. This thing gets mental. I've got to. I can't remember how to get out of this now. Right, okay. Here we go. Right, so set aside that, isn't it? Why didn't it let me? Okay. Got another station there, that. That's stronger. 545. That's stronger than 5505. How about that? Cheers, Derek. There's something down here as well. What is this? That's amateur radio down the bottom end of the band there. It is pretty good, Ricardo, yeah. It's got a few filters on it, but they're a bit harsh, really. Noise blinker. And if I go back to medium wave, for example, and if I mess with my antenna tuner, look, where are we? We're 1 meg. If I switch my antenna tuner and you watch the signal, and I've not got the RF gain right up. So we click on, let's go 5. So if I mess with my antenna tuner, it's not going to make much. So you can see how I can alter the signal. So I can lower the noise floor with it. So it's quite good fun, isn't it? Valve tester coming, wow. So yeah, there you go. 15 meters. So I need to tune my antenna tuner to yeah, there's plenty of action on there.
Looking for North America. From Italy, Zulu 8, Delta Echo Papa. Italy, Zulu 8, Delta Echo Papa. Speak louder for me, over.
This is working well, isn't it? Look at that signal.
Looking for stateside, looking for North America. From Italy, Zulu 8, Delta Echo Papa. Italy, Zulu 8, Delta Echo Papa.
He's quite wide.
QRZ stateside, North America. Security XCQ, hello, Security XCQ. Security XCQ, Security X on 17. Security XCQ, Security X on 17. From Italy, Zulu 8,
20 meters.
And 73 to now, so hopefully we hook up again and not, how much was it, 14 years, high between the next contact, so maybe a little bit earlier. So good luck to you there, and thank you, sir, DJ Nanayan.
There's loads of them on here, isn't there? Where is he? So there you are, a quick look at my SDR. But that's what I'm gonna try the active antenna out on. So that's the plan. You never know, it might be amazing. But that's my long wire out across the garden, apart from when we were on VHF, and that was my tri-band. Probably somewhere around there, but I can't remember off the top of my head. Yeah, Italy Zulu is Italy. They usually pump the power out, don't they? Right. I'm going to call that a day, people, anyway. I hope you've enjoyed that today. We haven't done YouTube channel of the week yet. I just don't know. What could we have as YouTube channel of the week? What could we have as YouTube channel of the week? How about Tony Albus? Have we had Tony before? Let's go with Tony. He's a cracking lad. Good chap, Tony. I've got to assume that you're subbed to Tony. I mean, he does drop in the stream occasionally. I haven't seen him for a while, mind you, but he does drop in from time to time. So I'll pop Tony in as our channel of the week this week. He does lots of test equipment. In fact, he does loads of test equipment, but he does test out other bits and pieces as well. He's quite a popular chap. Always happy, Tony. So there we go. Shout out for Tony there. A lot of test gear. If you're into your test gear and you want comparisons, or you want to see teardowns of it, then Tony's your man. He's tested out quite a bit of other kit as well. I know he did one on extractors a while back. Look at that old Simpson meter. Look. Yeah, clever bloke, Tony. Really good channel. He's got quite a lot of subs, I think. What's his subscriber count looking like? 17,000. Oh. So I'll add Tony in as our channel of the week. If you're not subscribed to Tony, I'd be surprised. But, you know, there you are. Another one for you to have a look at if you're bored. So, another one. His English is better than mine. He is a cheerful chappy, isn't it? So there you go. A computer radio. It's good stuff. So yeah, sorry it's been a little bit of a bitty live stream today. As I say, I wasn't going to go on for as long as this really, but I've managed to find stuff to do, so we're all good. But you can see I'm getting a bit hot. You see my arms were resting against the table there. Anyway, catch you soon, and hopefully I'll get this mini whip that John sent me built soon. I just need to find some decent enclosures. So don't forget, like it, and again our condolences to poor old Chris. Bye for now.